Welcome back. This is Professor. Hi, welcome back. This is Professor Edge, and today's lesson on the review chapter, section 7, radical notation and rational exponents. Our first definition is nth root. A number C is said to be the nth root of A if C, the nth power, so C the nth power equals A. Okay, so if you recall, we use this symbol for root. This is the nth root of A. Okay, so the cube root of 8, we're asking for this definition, we're looking for, so here's the thought process. We want what to the third power equals 8. Okay, so let's see, so 2 cubed equals 8, so that means 2 is the cube root of 8. Okay, so the cube root of 8 equals 2. Okay, so it's just the reverse of cubing. So if we had numbers x cubed, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, then if we go backwards, going this way, x would be 1, 8, 27, 64, and then the cube root would be, okay, so the cube root of 64 is 4. The cube root of 27 would be 3. The cube root of 27 would be 3. The cube root of 125 would be 5. And I'll remind you there's a button on your calculator for cube root, so make sure you know how to use it. And also remember the symbol is for if it's an even power, or index I should say, if n is even, so that's the index, then that is the principal, which is the positive one. So for square roots, fourth roots, so on, they have two answers for them, but when you do the principal, nth root is positive. So for instance, the square root of 4, by the definition written up there, 2 squared equals 4, but so does, okay, so 2 is a square root of 4. But negative 2 squared is also 4, so negative 2 is a square root of 4. But by definition, this is the principal square root of 4, which is just the positive one. If I want the negative one, I put that negative sign out in front. Okay, so just want to remind you of that. So, and that's same for, you know, if I did like the fourth root of 81, that's going to be 3. Okay? Now if I did the sixth root of negative 9, that's undefined, because if it's an even power, even index, you can't get a real number that's to an even power to be equal to a negative. So that's still true too, just like for square roots. So square root, actually, instead of saying undefined, we want to say not real, because we can define it using imaginary. Alright, so it's not real. So square root of negative 81, I mean, that's not real also. But if you did cube root of negative 27, since that's an odd power, negative 3 times negative 3 times negative 3 is negative 27. So that's fine. Okay, let's review the properties of radicals. And so our qualifiers, A and B, are any real numbers or expressions for which the given roots exist. And for any natural numbers m and n, here are properties. If n's even, this is what we were alluding to earlier, the nth root of a to the n, now a lot of people get this wrong and will just say it's a, but the answer is it's the absolute value of a, because if n's even, we got to guarantee that our answer is going to be a positive number. Oops. Sorry. The absolute value of a. If n's odd, we don't have to worry about it because it could be positive or negative. So this one's just a with no absolute value. Okay, number 3. Nth root of a times nth root of b. Now if the indexes match, you can multiply them together inside the radicand. So it's a times b. It's the nth root of a times b. And then dividing. So if we have a fraction inside an nth root, we can split out into the nth root of the top divided by the nth root of the bottom. And we can do this rule both directions. And of course b cannot equal 0. And then the 5th one, the nth root of a to the m is equal to the nth root of a, you can move that exponent to the outside. Alright, so those are some properties of radicals that should be reviewed for you. So let's try a couple of problems. A square root of 12 times square root of 15, they're both square roots, so I can multiply inside. And what I like to do is I factor things all the way down. So if 12 is 2 times 2 times 3 times 3 times 5. And since 15 is, since we're doing square root, we're looking for pairs. 2 factors inside make 1 factor outside. See that 2 squared, square root of 2 squared is just 2. Square root of 3 squared is 3. And then you got the 5 left inside. So my answer is 6 square root of 5. Cube root of, say, 20 times the cube root of 75. So again, they're both cube roots, so I'm going to put them inside. 20 times 75. Now I'm going to factor everything. 20 is 2 times 2 times 5. 75 is 5 times 5 times 3. So look, I have 3 of a kind. 3 5s inside, make 1 5 outside. And I got the 2, 2, 3 left inside, which is 12. Okay, my first step is I'm going to reduce the fraction inside. So let's see, a 2 will cancel with the 250. So that would get me 125. And then a z would cancel, and that would get me z cubed. Okay, now we split it up, cube root of the top divided by the cube root of the bottom. Cube root of 125 is 5. Cube root of z cubed is z. So there, I'm done with that one. Alright, now let's review simplifying like radicals. Look at this one. Oops. 2 square root of 32 plus 3 square root of 8 minus 4 square root of 18. Again, what I do is I simplify each of the radicals. So 32 is 2 times 2 times 2 times 2 times 2. 8's 2 times 2 times 2. And 18's 2 times 3 times 3. So we're going to get 2 2's out of the first one. They come out to the front, so that's going to give me 2, 2, 2, square root of 2, which is 8 square root of 2. Here just 1 comes out, so 2 times 3, which is 6 square root of 2. And then 3 comes out, square root of 2 stays inside, which is 12. And now these are like radical terms. They all have the square root of 2 in it, so it's kind of like you do with, like if it was an x. If I asked you, what's 8x plus 6x minus 12x, you'd have no problem telling me 8 plus 6 is 14 minus 12 is 2x. Well, that's exactly the same technique you use for like radicals. 8 minus 6 minus, or 8 plus 6 minus 12 would get me 2, and then the x in this case would be square root of 2. Okay. Alright, so that kind of concludes the review for radicals. R7, go to My Math Lab, complete your exercises there. Oh, I'm sorry, I got a couple more concepts to cover with you, so jump the gun. Okay, so let's review rationalizing the denominator. So if I have square root of 2/3, so again, I'm going to see if I can simplify in the radican 2/3. Can't. So if I can't, then I split it up into square root of top, square root of bottom. And if you recall, you're not allowed to have a radical on the bottom. So what you do is you have to rationalize the denominator. So you multiply by 1 so that we have 2 3's, square root of 3 times 3, which is just 3, right? That's square root of 9, which is 3. And now it's a rational number. So that's why it's called rationalizing the denominator. Okay? So that's how you do it. Now we use that same technique for cube roots. So if I did cube root of, say, 5/4, cube root of 5, cube root of 4. Now, I'm not going to multiply by 4 times 4 because the idea is I need 3 of a kind to make it perfect. I need a perfect cube. So what I do is I look at it factored, and 4 is 2 times 2, so I'm missing 1 2. I need another 2. So I'm going to multiply by cube root of 2. And that's going to give me cube root of 10 on top. And then I got 1, 2, 3 2's inside, make 1 2 outside. So let's try this one. If I wanted to do cube root of say 75 on the bottom, and we'll just say 1 on top. So what I'm going to do is again look at it factored and 75 is 3 times 5 times 5. Now again, I want to I want a 3 of a kind, right? I want a perfect cubes. So I only have one 3 inside, so I need 2 more 3s. I have 2 5s, so I only need 1 more 5. And so now what we get on the bottom is we have cube root of, there's going to be 3 3s and 3 5s. So the 3 3s make a 3, the 3 5s make a 5 on the outside. So 9, 45. And of course I wouldn't show all this work, I'm just trying to give you a little feel of how I do things. Let's do another one of those. So if I had, let's do it with variables. Say 1 over, say 5th root x squared y cubed z. To rationalize it, I want 5 of a kinds. So I need 5 x's to come outside the radical. Oops, that should be 5. Okay, so I have 2 inside, so that means I need 3 more to complete it. Y cubed, I need 2 more to get to the 5. Once you do the bottom, you do the top. Z to the first, I need 4 more z's to complete it. So we got the 5th root of x cubed y squared z to the 4th over, and then now we have 5 x's. X to the 5th, 5th root of x 5th is x. Y to the 5th, 5th root of y to the 5th is y. Z to the 5th, 5th root of z to the 5th is z. So that's rationalizing the denominator. And then of course, then we got even a little bit harder than that is on these with like binomials, you have to, if I just multiply the bottom by square root of 2, that gets rid of the square root of 2 for one of them, but then it appears in the other term. So what I have to do is multiply by the conjugate. And the conjugate, remember conjugate. If you have square root of a plus square root of b, the conjugate would be it's the thing that makes a difference of squares. Okay, so those are conjugates of each other. So I got 5 minus square root of 2. The conjugate would be 5 plus square root of 2. Alright, so now we're going to distribute. Okay, let's do the easy one, the bottom. It's going to be 5 squared, which is 25, minus square root of 2 squared, which is 2. The top I got to distribute. So 8 times 5 is 40. 8 times square root of 2. Then I got to distribute the square root of 6. So that's negative 5 square root of 6. And negative square root of 12, which is, let's see, it's 2 times 2 times 3. So 2 comes out, 3 stays in. Then I want to simplify, combine like terms. There aren't any, so just write them all down. And then 25 divided, or minus 2 is 23. And that's it. Alright, now rational exponents. X to the m over n is equal to the nth root of x to the m, by definition. Okay, so this is exponential notation. And then this is radical notation. Convert to radical notation. So if we have x to the 2/3, well, okay, so the bottom of the rational exponent, the denominator, that's going to be your index, and then x squared. Okay, and then, okay, it says convert radical notation and simplify if possible. Okay, so for A you can't. But for B we can. 4 to the 7/2. Well, that's going to be the square root of 4 to the 7th. And remember from before, we already wrote this rule. We could do the square root of 4 first and then pick the 7th. So that's going to give me 2 to the 7th, which is a big number. 2, 4, 8, 16, 32, 64, 128. Alright. Now let's go the other direction, convert to exponential notation. So again, remember the index of the root is going to be your denominator for your rational exponent, and then the power is the numerator. So the power is 5. So 4th root of 13 to the 5th is 13 to the 5/4. Cube root of 20 squared. Again, the index is the denominator, 2 is the power, so that's the numerator. So it's simple as that. Alright, now if you have different power indexes, or indices would be the plural. Look at this one, cube root of the 4th root of 7. So if I convert this to exponents, so I got the 4th root of 7 is this, 7 to the 1/4, and then the cube root of that would be 7 to the 1/3. And then using exponent rules, we can do power to power. You multiply the powers, so you get 7 to the 1/12. Okay? So if we did the cube root of 2, cube root of 2 times the square root of 2, on this one, this is 2 to the 3rd times 2 to the 1/2. And again, using exponents rules, if we're multiplying the same base, you're going to add the exponents. So what's 1/2 plus, or 1/3 plus 1/2? So you got to get common denominators. So that'd be 2/6. So that'd be 2/6 plus 2, 3, 6, which equals 5/6. So this is 2 to the 5/6. Okay? Write as a single radical notation and simplify. So let's try square root of 2 times 4th root of 8. So that's going to be 2. So the normal trick is you convert it to rational exponents. And if you want one radical, you got to get common denominators. So then 1/2 is going to be 2/4, So now I have common denominators. And then now I can write it back as radicals. So the fourth root of 2 squared, which is 4. The fourth root of 8. I guess I shouldn't have skipped that step, right? So it's the fourth root of 2 squared. It's the fourth root of 8. So the fourth root of 2 squared is 4. Fourth root of 4. Now, since we have common indices, they're both fourth root, I can multiply the numbers inside, which gets me the fourth root of 32. But remember, I'm going to simplify it, so I need to factor it all the way out. I'm looking for a 4 of a kind. So 2 comes out, and the 2 stays inside. So it's 2 fourth root of 2. Okay, so that's generally the trick that you do for those. Alright, so that concludes the lesson review section 7. Go to My Math Lab, do your homework there, and I will see you in class.